போகணுன்றதுனா ஓகே ரைட். உங்கள் கேமரா வந்து இருக்கீங்களா சார்? இருக்கீங்களா? நானே ஹலோ என்ன இடத்துல இருக்கு? Hello? 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 ஹலோ ஹலோ இங்கேருந்து போக மாட்டேங்குது போச்சுன்னா இந்த ஸ்பீட் தனியாக கேட்கும் அது காதில். ரொம்ப லேட்டாக கேட்குது. ஆரம்பிக்கலாங்க. ஹலோ, அது எப்படிப்பா உடனே உடனே பண்ண முடியும்? உடனே உடனே எப்படி பண்ணுறது? புரியல. ரெண்டு பேர் லைவ்ல இருக்காங்களா? ஸ்டார்ட் பண்ணட்டுமா? பண்ணிட்டேனே, ஆன்ல தான் இருக்கு. Right. So then, as per the schedule, today is the first class for the subject thermodynamics. And before we go deep into the subject, we will have to first see the elaboration for the word thermodynamics itself. And all of you know that thermo is related to heat. Dynamics means, of course, it is with respect to motion. Well, dynamics is a derivative of the word mechanics. Mechanics has got two groups. One is dynamics and the other one is statics. Whenever we refer to bodies that is at rest, it comes under the study of statics. So the other way around, when it comes to dynamics, it will refer to motion. So now combine the two. Thermo refers to heat, dynamics is with respect to motion. And it means that when heat is supplied, we are able to get motion. But when heat is supplied, that has got so much of details so that this very definition itself will take quite some time for understanding it well. We will go to a little bit of more basics. When we supply energy, and for energy, according to definition, work must be done. Energy is defined as the capacity to do work. So whatever work is done, that is energy we supply or it is stored in the body. And work done, if you take mechanics into account, is force multiplied by displacement. Force multiplied displacement. And force is what? Push or pull that we apply. Of course, for force there is a separate definition. And I don't want to go into the details about whatever is there in mechanics. Force is that which changes or tends to change the state of rest or of uniform motion of a body. So all that you can study under mechanics. Then force multiplied distance is work. So see there we have got distance. So when a force is applied and distance is covered, work is done. Here what happens is that when energy is supplied, when energy means it is equal to work done. Work done is equal to force multiplied by, we will use the symbol S for distance. And when it comes to liquid or maybe gases, this force will be equal to pressure multiplied by area. We are going to see more details about pressure and the area as well, because that itself is our subject, into the displacement. Area into distance covered will be equal to the volume. So we thus have the energy supplied will be equal to pressure multiplied by the volume. So when heat is supplied, that energy is going to the gas, so there is a rise in the pressure. Because of that rise in the pressure, it will be giving a pushing effect to the gas. And due to that pushing effect, motion is there. So because of heat, we are getting motion. So for that, the combination is what is known as thermodynamics. Okay. So we have just now seen that the study of thermodynamics involves energy, involves pressure, involves volume also. And heat, you can see, has got a connection directly with the temperature. So when heat is supplied and the temperature increases, that only will bring us an increase in pressure and also a change in the volume. So temperature, pressure and volume should be involved. And this temperature, pressure and volume are all, that combination are known as the fundamental properties. Fundamental properties of the system. Okay, so whatever I have told you, if all that together, then what we will be getting is the actual definition of thermodynamics. So say what we have: energy, heat, and when heat is applied, we get work. So energy, heat, conversion of heat into work, and apart from that, for this heat and work combination, it has got a relationship with the various properties of the system. So look into the definition now. Thermodynamics is a field of science that deals with the energy possessed by gases and vapors. You see, when you study the details, that is energy details for a solid, that is what we study under mechanics. And when you study the energy details of liquids, is what we have under fluid mechanics. So what is now left out is gas or maybe a vapor. Steam is a vapor, air, oxygen, nitrogen, hydrogen are all gases. So for all that, when you make the same detailed study which I have told you for mechanics and fluid mechanics, then it will come under the category of thermodynamics. So mention that in the definition. It is a field of science that deals with the energy possessed by gases and vapors. Its conversion in terms of heat and work. So how it is getting converted, these details. In terms of heat and work, of heat and work. and the relationship with the various properties of the system. It is a field of science that deals with the energy possessed by gases and vapors, conversion of that in terms of heat and work, and the relationship with the various properties of the system. For example, if you supply heat because of which the temperature increases very high, then the pressure will also increase high, or the volume will increase plenty. When volume increases more, then the gas, let us say it is inside the engine. Engine means piston will be there, cylinder will be there. So when the gas is having more and more increase in the volume, then the gas will push the piston more and more. Piston has got a connection. From that we will get the output outside. All that we are going to see in complete details, one after the other. So when volume increases more, we will get more work from the piston. Piston is pushing some body outside, so the body will get more energy. So more work will be done. Supposing the volume change is less motion of the piston, will get less work. So that is why a study of all the property details is a must. How we must study the heat, under what situation? Temperature is not changing but heat is supplied. Or pressure is not changing and heat is supplied. So like that, when you analyze the different conditions that is there for the properties, also known as the pressure, volume and temperature, then there will be a particular condition for which the output you get will be maximum. Of course, output divided by input is efficiency. When heat is involved, it is a question of thermodynamics, then the efficiency because of that is what is called thermal efficiency. Efficiency is output here, work is the output, this is the input, this output divided by input is equal to the efficiency. So for getting the maximum efficiency, how are these values, that is the properties, changing? That is what we will have to find out. Of course, then another thing is that there was one new system, new word that I had mentioned, and that word was system. It is a field of science that deals with the energy possessed by gases and vapors, its conversion in terms of heat and work, and the relationship between the various properties of the system. There, you have got the word system. So in the first place, what you have to understand so that this definition is complete is the word system itself. Okay. The definition for system goes like this. Reference to any space, a matter, or a group of matter within a definite boundary, whether real or imaginary, is a system. Now, this definition is a general one. You can use it for any subjects, you can use it for your real life, you can use it for, what is that, a building even. So reference to any space. Reference means to speak. I am referring to thermodynamics, means I am speaking about thermodynamics. So reference to any space, the space inside the room. What is there to speak about the space here? So many things you can say. The temperature, because of the hot sun outside, is more. In the room, it is cool. So the temperature inside the room is less. So I am speaking about the space in the room, man. Yes. So reference to any space. A matter or a group of matter. Matter is anything that occupies the space and has weight. So under matter you can bring anything. The computer by way of which you are watching this class, that is one matter. And then in your room you have got a tube light, fan, or maybe you would have put the AC on and so on. All are different matters. Now look into it. Reference to any space, a matter or a group of matter within a definite boundary. Note that point, it is a very important word. As we study further, you will then understand how important is the word boundary. You see, this is system, and apart from the properties, these are the terms which are normally ignored by students. Even some faculties ignore it. But now itself I say it, take it for granted that straight away you will be losing 20% of the marks. If you have got not much idea about the system. Attached to the system is another word called surroundings. So if you don't have idea about system, surroundings and properties and so on, that's all, man, you are finished, gone. Okay. So now let us try to understand all about a system. Reference to any space, a matter or a group of matter. You have to speak about a space, otherwise you have to speak about some matter. For example, the tube light in the room is above the fan, tube light, fan below. So it is above the fan. So the light from the tube is affected by the height of the fan. So the light is not reaching our table properly. Hence, the notebook appears to be a little bit dull. We are not able to write everything clearly. So I am speaking about the light, the fan, and apart from that, I am speaking about your notebook, pen, and also the table. So like that, if you speak about any one matter, that is also enough. But I am now speaking about a group of matters, so many. Everything put up together is one system. That's all. So, reference to any space, a matter, or a group of matters within a definite boundary, whether real or imaginary, is a system. So further, when we look into the explanation, reference to any space, so speak about some space. A matter, speak about any one object. A group of matter, you can speak about a number of matters. All that is equal to only one system within a definite boundary. So, you have to select a boundary for that. Okay, so you will have to select a boundary for that. And that boundary, what is said about it furthermore is it can be a real boundary or an imaginary boundary. So for a real boundary, you take the walls of this room. You can feel it. You can see that you can feel it. Wall also you can feel it. Yes. Now you can understand that something is there. So it is a real boundary. Instead of that, the boundary can also be imaginary. Say 6 inches before the wall. So you can see the gap if I turn it. So even before the wall, if you imagine that there is a line, there is a boundary, it doesn't matter. Inside that, if there is any matter and you are speaking about it, then that is also a system. Right. So reference to any space, a matter or a group of matter within a definite boundary is a system. When you study about thermodynamics, you can also add it up. It's a thermodynamic system, but not necessary. So reference to any space, a matter, any object, or a group of matter, fan, tube light, table, pen, notebook, all of that you are speaking at a time. So that's why it is all equal to only one system within a definite boundary. So boundary, I have told you what is it, whether real or imaginary. So it can be a definite boundary, like the walls of this room or the walls of your room. Or it can be an imaginary boundary also. So you have to visualize that there is one line in front of the wall. Doesn't matter, let it be. Inside that, if there is something and you are speaking about it, then that will become a system. You have to now understand two things. Or say, one important information, which is like this. Particularly in thermodynamics, it is of utmost use. For all the subjects, you can even take medical subjects. There also, this will hold good. In the entire world, you say, any definition, you will have to put forth 2 points. Yes. So, what we have now got for the definition of a system is reference to any space or any matter or a group of matter. This is one. Within a definite boundary, this is second. So any definition like that you take, it will have two information. If you are giving only one information, definition is wrong, or I will say, put it in a decent matter, is incomplete. So the definition goes incomplete. So that is why any definition in the world, whether it is physics, chemistry, mathematics, thermodynamics, or material science, or maybe any biological or science subject, any definition, two information. You are now studying a new subject, say biology, but in that some definition is given. You don't know anything about that definition, but you watch that there is only one point. You can tell, sir, I don't know biology, but the definition is wrong. You can say it like that straight away. Okay, so remember the entire, all the definition in the world, whether it is economics, commerce, engineering, or whatever. Two information not given, then the definition is wrong. So reference to any space, a matter, or a group of matter. One information. Within a definite boundary, second information. Now the definition is correct. Within a definite boundary, whether real or imaginary, is the system. So now, to understand this much better, let us take an example. Because our subject is thermodynamics, so let us take an example that is there in thermodynamics. Well, in our study, most of the times, you see thermodynamics has got two divisions. One is all about gases, another is all about vapors. We are going to study both. Vapor, mostly we are going to study about steam. A little bit of refrigeration is also there. Then it is so many vapors when you take refrigeration. So then, different kind of vapors or a gas is what we are having under thermodynamics. And as far as a gas is concerned, mostly it is going to be an engine or maybe a compressor. And there are, of course, pneumatics also. So there is an involvement of a gas. Gas means normally it is the engine. And all of you know that the engine comprises of the cylinder and then a piston. Of course, engine means there will be a valve. For the timing, we will not take into account. So a cylinder, piston, and from that is from the piston, a rod will be coming out. This connects the input and the output. See, I have told you sometime before, gas will push the piston when volume is more pushing, more output. So the gas pushing the piston, that is the input here. Piston will move, more output is available. That output from the piston is going to this rod. So this is connecting output and input. That's why this rod is called the connecting rod. And to this connecting rod, we have got one more rod, and that rod is known as the crank rod. So what happens is, one end of the connecting rod is pushed to the piston, which is an up and down motion. Another end is connected to a rotating body, crank rod. So the up and down motion of the connecting rod is converted on the other side to rotation, from where we will get the output. See, there is a rod attached to this crank rod. You can only see a circle when you see it directly. So we will imagine that this rod is turned by 90 degrees. So imagine then you will see the shape of the rod like this. Okay. So it's like this. So then, connecting rod, this is called the crank rod because rotation is like that of a crank. And apart from that, what comes outside, which is from, if you see from your direction, it is circular. That only I have shown here. That is known as the shaft. Or it is attached to the crank, so it is known as the crank shaft. Because all this mechanism is called the engine, so this shaft is known as the engine shaft or the engine shaft. So what we do is, of course, here, this entire space between the cylinder and the piston, you can see it is filled with a gas. And we supply heat to this gas. See, everything that we have studied is now coming here. Because of which the gas becomes hot, temperature increases, that increase in temperature will give a push effect, and so you will see change in the pressure and the volume. Let us say because of that, the piston moves from top to bottom. So like this. Finally piston is here, so see the increase in the volume. Because of that, gas will push the piston, and on the other side we will get rotation, and this shaft, which is also under rotation, there only, to this shaft only, a wheel is attached. That is the wheel of our automobile man, scooter, motorcycle, bus, car, lorry, and any other truck and so on. So then what happens is therefore what happens is that here at the shaft only, a big rotating body which is attached to scooters and motorcycles. This is rotation, wheel is attached, so wheel also will have a rotation. When the wheel has got a rotation that is attached to the body, scooter or motorcycle, so scooter goes forward. This is output we get. All about this input and output is what we are going to study in our subject. That output by input for engines is what is called the efficiency. And of course, more details are there about efficiency, which we will see later on. Okay. So then, I have given you an idea about, in general, concisely, about the working of the engine. For that, let us imagine that just inside the cylinder, we have taken a boundary. That blue color is the boundary. So this is the boundary. Can you tell me something about the boundary? The cylinder itself is not the boundary. If you have taken the cylinder as the boundary, it will be a solid boundary. No, just a little bit, maybe 2 mm. Below that, we have selected a line, imaginary line. That is an imaginary boundary, therefore. And whenever we speak about the output which we are getting due to rotation, how do we get the output? Because gas is pushing the piston. So we have to speak about the gas. Next question, where is the gas? Gas is inside the boundary. So, according to our definition, therefore this gas becomes a system. I am speaking about the gas. Gas has got its boundary, both the definition, okay. So according to that definition, the gas will be a system. Right. Supposing you draw another bigger boundary, a different boundary. So I'll erase a part of whatever I have told you. Right. So for this engine, we have got the piston, then the connecting rod, crank rod, and other things like that. And what we have done is we have selected a boundary. Boundary has been selected. We will call this as a boundary B1. And another boundary, we will select it, say outside the cylinder. So this is B2. Now, can you give me some details about both the boundaries? One is boundary B1, just inside the cylinder, and boundary B2 covers the cylinder also. So even the cylinder is now outside. Right. So, very much attached to the system is another definition called the surroundings. So I am going to discuss about the surroundings to all of you. The definition for a surrounding, please note that many books have given this definition wrongly. So that is why I am attending classes. Like what you are watching now is of significant importance. So at this stage, let me tell you something about myself. Name is Ramnath. Basically, I am from Chennai, but I can speak Hindi very well. Yes. Okay. Now, coming to the point, Ramnath, I have done my M.Tech. I am also a rank holder. I am the author of a book, same Thermodynamics. I am author. I have got an award 2 times for good teaching or best teaching from the central minister 2 times. And apart from that, I have gone abroad to a number of places. Malaysia, Singapore, all because of teaching. Then I have gone to USA also. Well, there are many things I can say like this about me, but too much will be too bad. Another thing is that in more classes to come, we are going to know more about each other. Okay. So then, I was talking about the system and the boundaries. So, we have selected 2 boundaries. Cylinder B1. One cylinder is B2. So, for the boundary B1, the cylinder is outside. So, let us see what the cylinder will do here. Or we have to find out for the boundary B1 whether the cylinder is a system or a surrounding. For B1, the cylinder is outside. So, note that point. So, the definition for a surrounding is that any matter that is outside the boundary and affects the behavior of the system inside is defined as a surrounding. So, system, then boundary, then outside surrounding. So now, gas inside, we have got a boundary. So according to the definition, the gas is a system. Outside this gas, outside this boundary B1, we have got a cylinder. But just outside the boundary is not enough. Second point, I have told you every definition 2 points are important. Without that, the definition is not complete, or you can also say that the definition is wrong. So what is the second point? Outside the boundary is okay. The second point is, it should affect the behavior of the system. It should change the characteristics of the system. Inside the boundary, what we are having is the gas, called the system. So if the cylinder outside the boundary is changing the characteristics of the gas. So 2 points, outside the boundary. Second, changing the character of the gas, 2 points. Then that matter is known as a surrounding. So system, 2 points. Surrounding, again 2 points. So now, let us try to find out the details about the cylinder. It is outside the boundary, one thing. Whether it is satisfying the second point or not, to understand that, let us imagine what will happen if the cylinder is not there. The cylinder is removed, gone. Then only piston is there. That's all. Cylinder gone. And boundary B1 is also there. So now what will happen? See, this is all open, note that point. I am showing only a boundary, that's all. It doesn't mean that it is a solid. It is a boundary which is imaginary. So now you can see that here there is some space, here also, and even here. So the cylinder, you have got open space in all the directions. Then what will happen? When it is open, the gas will flow in all the directions. When the cylinder was there, then it is blocking the way in 3 different directions, 1, 2, 3. The gas is now able to move only in the direction of the piston. Piston moves because gas is pushing the piston. So here, the gas is moving in only one direction. It can move in all the directions. Cylinder is removed. So cylinder is restricting the movement of the gas. So cylinder is affecting the behavior of the gas. So the cylinder is outside, it is outside this boundary. It is also changing the characteristic of the gas inside, 2 points. Because of that, if you take the boundary B1, For that, if we take this boundary B1, for that the cylinder is outside. It is also changing the behavior of the character of the system. So both conditions satisfied. Therefore, cylinder satisfies both the point for the surrounding definition. Therefore, cylinder is a surrounding, but for the boundary B1. If the boundary is changing, then what will happen? Just see it. Take boundary B2. The cylinder is inside the boundary. And we have to speak about the cylinder, it is a must. Say it is like this. My engine is giving good amount of work output. How? Gas is having a movement, very efficiently the movement of the gas. Where is the gas? Gas is inside the cylinder. So you have to talk about the cylinder whenever you speak about the engine. So cylinder is inside the boundary B2. We have to speak about the cylinder. So both conditions satisfied for the word system here. So here cylinder becomes a system. So see the difference. For the boundary B1, cylinder is outside affecting the gas. So it becomes a surrounding. For the boundary B2, cylinder is inside. Also, we have to make a mention of it. So then the cylinder becomes a system for the boundary B2, becomes a surrounding for the boundary B1. So, now you would have understood properly that there is a definite difference for the different boundaries that we are having covering the systems. One, and then two. So now we have got the definition that we are having for the system. Then we have got boundary, about which I have given enough of information. Lastly, we have also got the details for surroundings. Okay. So now, when we speak about thermodynamics, there will be heat supply and that will be converted into work. How much work it is, more or less? It depends upon how best we are making use of the energy supply. So to understand all that, the system which we have known just now is of three different types. Right. So for the time being, I will move this screen. I will move this screen and then so that I can get some space for explanation. Now coming back to the point. So dear students, whoever is watching this episode, you can somehow inform me that you are copying it down, not fully copied or whatever. So I'll wait for some time. It's okay. Then now coming to the point, I was talking to you about the different type of systems. Types of systems. One type of system is called the closed system. The other type of system that we have is known as the open or the flow system. And the third one is the isolated system. So now we have to understand the details about all of them, because different type of systems you have. The engine, the piston cylinder arrangement that we have studied is a closed system. The definition for a closed system is that only energy will go out. No mass will be coming out. So no. Here you can see between the cylinder and the piston. It is a completely closed unit. Mass cannot go out. But energy is transferred from the gas to the piston to the connecting rod and so on. Now you can see that the energy is coming out of the boundary. So that is the example for a closed system. So if somebody is asking you, give me an example for a closed system, then the answer is that a gas inside a piston cylinder arrangement is a good example for a closed system. Then, next one. Let us take a pipe. So let us take a pipe. And what you do is that take some boundary. It's a boundary, I am showing it only a part of it. That part which we want to understand the flow details. So if you see the flow, gas is flowing. And when the tube is full, whatever fresh gas is entering, same amount of gas also should come out. So flow is there, entry is there, exit is also there. That is why here you can see the boundary is open. Because of the boundary open, flow is taking place. That is why the gas that we are having here inside this boundary is called the flow system. Because the surrounding is now, not surrounding, the boundary is now open at 2 points. So if you want to see that open properly, it is like this. So it is. Okay. I will show it even more clearly. It is like this. Yes. So this you can see the boundary is open on both sides. That is why the system here is called the open system. Flow is taking place. So the same system is also known as the flow system. If the flow is taking place uniformly, for 5 minutes always 500 grams of the fluid, of the gas or whatever it is flowing continuously, then that system is called the uniform flow system. Okay. So, closed system, the piston cylinder arrangement was example, and gas filled inside and a boundary selected inside the cylinder. Then for a flow system, the boundary is open for the flow. That is why here the system, that is the gas which we are having, is known as the flow or open system. If this flow is taking place in a uniform manner, then that system is called the uniform flow system. So what is a good example for the flow system? See, when you are having big size pipe, then it is not called the pipe, it is known as a duct. Good example for that is the pipe which we are having in air conditioners. It's a centralized air conditioner. Big hall, the entire hall is air conditioned. So for that we are having large size pipes which are connected so that it will cover the entire space. Don't use the word pipe there. It is a duct. That is why air conditioning duct, designing of that duct, it's a very, very big study under air conditioning. So when action is going on, gas flows. Like that, when action is going on, then the pipe is called a duct. Pipe simply lying somewhere, no gas flowing, nothing, then it is called a pipe. Or to bring both and complete one sentence, it is when a fluid flows through a pipe, then that pipe is known as a duct. Okay. So now, the example for the flow system is that there is boundary that is open and fluid is flowing. Uniform flow, it is called the uniform flow system. So flow of fluid through a duct, through a pipe, is a good example for the flow system. Okay. So now there was one third system also about which I had given some reference. So let us also look into that. Well, in the third system, when neither mass nor energy transfer takes place. Then that system is known as an isolated system. To understand this better, let us put it in our real life. See, whatever you study in different subjects, if you compare it with our real life, if you compare it with our real life, what you will find is they are same exactly. So wherever it is a complex matter, wherever it is a question of difficulty, equivalent of that, what we are having in our life, understand that you will find that the subject thermodynamics or any other subject for that matter is as easy as the word easy itself. So like that, what we have now is the third system called the isolated system. In this isolated system, there is no energy nor any mass transfer taking place. To understand this well, let us take an example with reference to what is happening in our life. You are having 100 rupees in your pocket. Or say, okay man, nowadays 100 is nothing. Say 500 rupees you are having in your pocket. Your friend is asking you, telephone. I'm having some difficulties, end of the month. Next month only I will get some money. So please help me. I want 100 rupees. So from 500 you can take 100. Afterwards he is telling you further some information. I am having some fever. So because of that, I am not able to move out. Can you please come to my room and give the money? So now what happens is, when your body is moving, mass is moving. When your body is coming out of your room is the boundary. When your body is coming out of the room, it means what? You are coming out of the boundary. So mass is crossing the boundary, and when your body is moving, means there will be some energy in your body which also will move out. So here what happens? If the room is the boundary, then both energy, mass, both are coming out of the boundary. So you are now a open or the flow system. Supposing your friend is coming to your house and taking away 100 rupees. Then you are remaining in the house only, but 100 rupees goes out. Energy is going out, but you remain inside the boundary. You are not going out. So here, energy transfer only. No mass transfer because you are inside the boundary. At that time, you are a very good example for a closed system. A closed system. After some time, you think, why I should give 100 rupees to that fellow? Supposing he doesn't return the money, I am at a big loss. So, no, safely, I'll keep it in my pocket, I will not give. So then what happens is, whatever boundary is there, money is not going out of the boundary. And you are also still remaining in the same room because you are not going out. So here no energy transfer, no mass transfer. At that time, you are a good example for an isolated system. The word isolation, meaning of that is separation. Isolated means you are separated from outside. You are separated from your friends. So that is why you become an isolated system. And I repeat it, isolated system means no energy transfer, no mass transfer. So there are three different types of systems. One is called the closed system. Only energy goes out, no mass. Again, both mass and energy transfer taking place. Okay. Then it is an example for the open or the flow system. Third one, no mass going out, no energy also going out. So that is a good example for an isolated system. Okay. Well, again coming back to yourself. Give the money to your friend, you remain inside. You become the closed system. And you are going to your friend's room to give the money. Then mass transfer, energy transfer also. You are wearing a nice shirt and a pant. All that will cost about 500 rupees. Or maybe 1000 rupees, even more also. So that is the energy going out when you go out. So this is again example for both mass and energy transfer. Suddenly one student said, "Sir, I am wearing cheap pant and cheap shirt, sir. It is available in the village where I am staying. Therefore, you cannot put any value for the pant and the shirt." Okay. Now, if we don't put any value for the pant and the shirt, but what is there is when you are going out, then there will be some energy inside your body. Leave out pant, leave out shirt. Money you are having in your pocket is negligible. So, all that when you say, then you cannot take that into account. Then, which is example for flow system? If somebody is asking, what about the energy in your body? Sir, that is also negligible. If that is negligible, no energy in your body, you cannot move even one step, man. Energy is force into distance. If energy is zero, distance is also zero. So, you cannot neglect energy inside your body. See, whatever energy is associated with the flow system, that has got no connection with the energy of the open hour flow system. In the energy transfer with the mass that we are having in the flow system, there the energy and the mass are integrated with one another. You cannot remove it separately, man. I am talking of that energy, which is therefore the energy inside your body. So that is a good example for a flow system when you are going out with the energy in your body. Right. So then, when you remain in the house, money is also there, and you are a good example for an isolated system. Well, if you see the thermodynamic books or thermal engineering books, what you will find is that the example for an isolated system is a bomb calorimeter. Because there is some fuel inside the calorimeter, by passing electric current, we ignite the fuel burns, and there is a water in that bomb calorimeter, the temperature of that water will increase. But it is fully sealed, nothing will come out. So here, what happens is, energy in the form of fuel is now going to water. That is also inside. Let it be in any form. The total energy is remaining inside. So here, no mass transfer, no energy transfer. So that is a good example for an isolated system. But we are at the beginning stage. How can we know about a bomb calorimeter which is studied after some time? You are new to that. So somehow I felt that this bomb calorimeter, if it is taken as an example for the isolated system, will not suffice. So that is why what I have done is that I have taken some other example, so that what is an isolated system and energy associated with it can be understood by everybody. See, let us take a flask. Now, I told you I am the author of a book, and I have written that book sometime during 1990 or so. So at that time, before that, bomb calorimeter only was taken as an example. After I wrote the book, then so many books came, and all of them have given the example as the flask only for an isolated system. You can see, after 90, so many books, they say flask. But before that, only bomb calorimeter. So my book was the first book which gave the example for a flask. It gave the example for an isolated system with the flask. Before that, no. I was the first person therefore. Alright. So, now I would like to tell you something more for your own benefit. See, what you are learning here is not for just one topic in one chapter, no. I will be covering the entire chapter, and like that I will be covering all the chapters in the syllabus. But the thing is that there are many other things I have to do, so I don't have all the time for covering in full details. See, we have got recording facilities. This is not recorded. You cannot. And apart from that, we have got other facilities, and apart from that, problem solving, tests will be conducted, and etc. How many marks you have got, and so on. And also, we will be giving you the solution, not just key, solution for the test. So all these facilities are available by paying a premium. You have to join us as a student. And believe it or not, for the entire syllabus, that will go for months. The charge is only just 4,750 rupees. So when you take any subject from outside, online only, people charge 3,000 rupees per month. So imagine 3-4 months means what? I am charging for all the 4 months or whatever it is. Just 4,500 rupees. In that, doubts will be clear. Recording will be there. So, same class you can see it a number of times. Then lot of problems will be solved. Tests will be conducted. Doubts will be cleared. And apart from that, the answer, the solution that is there for the test, that also will be worked out and sent to you. So these are all the facilities that you are having. So by paying a meager 5,000 rupees, you will have 500 times more benefit. So it will be definitely worth it. So please join. And telephone numbers are also given. And you can see it at the start of this web page. So you can call us. The office for the time being will work between 10 to 5. And during that hours of 10 to 5, you call us, you can ask the details. We will definitely explain you. And then thereafter, you can easily understand how beneficial it will be if you join us as a regular student. And for some students, even that 5,000, if they are not able to pay, that is why this free class which you are able to see here will cover the entire syllabus. That is my idea. Those who cannot afford even that 5,000, let them have the entire syllabus being covered with our YouTube streaming. So we will cover everything, but not in complete details. Time will be required for all that. So those who can afford, please join as a student. It will be very, very helpful for you. Another one big help, that you see, it is not that I will tell you little, stop, go to the next topic, nothing like that. I will cover in complete details, but lot of problems, recording facilities, all that will not be available. Otherwise, everything will be there. For all the efforts that I have taken, one request is that you please subscribe. Do subscribe, and also like symbol is there, click it. If possible, share it also. So these are all my requests. Okay then, coming back to the point. What I was telling you was the three different type of systems. One, closed system. No mass transfer, only energy transfer. Example for that was the gas inside, the piston cylinder arrangement. Then it was the open or the flow system. Further, the example was flow of fluid through a duct. Then isolated system. So I was just talking about the isolated system before briefing of something else. So now, what happened was the thermos flask. You know, thermos flask has got two layers. And between one layer and another layer, it is filled with vacuum. So this gap, it is filled with vacuum. There will be threads here, like this thread. There is a cork, and you can just rotate the cork, it will completely close the flask. Because of vacuum, no heat will go out. Of course, because it is sealed, no mass will go out, of course. So here, neither mass nor energy transfer. So it is completely separated from the outside environment, separated. This itself is the world for the system. So this is the world. World means what? All of you know, another name for the world is universe. So many questions are there using the word universe. So this gas inside the flask is the universe for the gas. Like that, find out what is the universe and you can solve the problem very easily. Okay. So here, no heat flow. Then from here, no mass flow. Okay. So now the gas. Why gas? You can also mention what is there really. Put hot water or milk. Put the gas. Okay, then it becomes thermodynamics. So, flask is not the isolated system. What you are having inside, that will be the isolated system because that only no mass flow, no energy flow. Only for the gas. See, before, when I was explaining this, I have mentioned about the flask a number of times. So that is why in most of the books what you will see is for the isolated system, flask is taken as the example. But that is not correct. Gas inside a thermos flask is what is the correct answer for an isolated system. Alright. So proceeding further, when we were talking about the different systems, we were also talking about the energy transfer. Flow system, both energy and mass transfer. Closed system, only energy transfer, no mass transfer and so on. So, we have to therefore associate the energy and the mass. So, for that closed system, what I have told you was gas inside a piston cylinder arrangement. This energy is different from the energy that is having attachment with the mass of the closed flow system or open system. So, what you have to tell is that energy associated with the closed system yes, this is system, surroundings and so on, for which not much of importance is given elsewhere. It means that the study of thermodynamics by you is incomplete. When you work out problem, then you can understand how important is that word surrounding. Okay, till then we will proceed further. Now, here what we have studied, that there is no mass transfer. Only energy transfer. This, which is associated with the closed system, is known as the transit energy. Okay. Let me elaborate about my teaching in the live YouTube streaming. Here I will be covering the entire syllabus for thermodynamics at college level, little portion that is there of thermodynamics for IIT JEE and also for NEET, and also what I will be covering is something which will be a complete study even for the UPSC examination that is there after engineering. Well, I have got quite some information about the UPSC examination. I have taught such students also. So there only even students who have completed their IIT were my students. Hundreds of students. So that UPSC examination which is there after engineering studies. So that if you clear it, it is a 1-year course, if you clear that, then straight away you will be taken as a deputy superintendent in railways, plant superintendent. Then you will be taken, otherwise depending upon the rank that you get, you may even be taken as a deputy general manager or deputy manager or something like that in government factories like Steel Authority of India Limited, or National Thermal Power Corporation, and so on and so forth. Some of my students are working under the ministers. Nitin Gadkari's technical advisor is my student. Piyush Chawla, who is himself the energy minister, under him the deputy director for science and engineering is again my student. So because of all those experience I am telling you, even at that level I have taught students. And whatever be the syllabus that I will be covering here, YouTube streaming, it will cover all the type of examination that I have mentioned just now. So quite a useful information for engineering and as well as other type of courses. Quite some information will be there for even those students who are appearing for the IIT entrance examination. Useful for all of them. Okay. So now I had told you about the definition of thermodynamics, then what is the system, what is the surrounding, and the different type of system, and we are now discussing about the energy transfer, the energy associated with the different system. In the case of closed system, when there is no mass transfer but only energy transfer takes place, then this energy is called the transit energy. And in the case of the open or the flow system, so for the open or the flow system, the energy associated with this also is known as the flow energy only. Is called the flow energy. All right. There is one more system we have studied called the isolated system. No mass flow, no energy transfer. Even if flow is there, still some energy is there which remains constant inside. Example for that is the internal energy. What is that internal energy? It has got an equation, it has got a definition. All that we are going to study it under the first law of thermodynamics. See, lot of equations are there. I will derive those equations. Lot of problems are also there. I will work out all these problems. But don't expect too much. For that you have to join us as a student. It will be highly beneficial to all of you. Okay. So then, now, I was talking to you about, also talking to you about the isolated system. Isolated means completely separated. The universe itself is, the system itself is equal to the universe there. So now, the energy that is associated with the isolated system, where no flow is there. Even if flow is there, still there is one energy that will remain inside only. Example for that is the internal energy. So internal energy is the example. Energy. What is this internal energy? I don't want to say it now because half-heartedly one day you will be able to understand it. Okay. So that is why we will see it later on. For the time being, you just think that internal energy, symbol for that is U, is equal to mass into, there is one term called specific heat. And you will be all knowing what is that specific heat, you know the definition. Still, I am also will be giving you the complete details about it. Into the temperature. So here, even if you take a flow system, flow is there, then also this energy will remain the same inside the boundary. What happens is when 50 grams mass is coming inside, flow system means there will be continuous flow. Then 50 gram mass will be going outside also. Say inside, let us say that there are 400 grams. 50 going in becomes 450. 50 coming out becomes 400 again. So mass will be the same, even if it is a flow system. The specific heat for a particular gas is a fixed value. So that is also a constant. And when flow takes place, take a tank filled with water. Below that we are having a pipe. Open the pipe. Some water will come from the tank. If we keep the pipe open, more water will come to the pipe from the same tank. So from the same tank, when more and more flow is there, same tank, therefore temperature also will be the same. So this also remains constant. This combination is what is called the internal energy, where the total energy remains the same. So energy remaining the same inside the bound remains. It is a very good example for stored energy. So what we have is, for the closed system, transit energy. For the open or flow system, it is known as the open or flow energy, which I have shown it on the other side. We have got energy remaining constant. The example for that is the stored energy. One more example for stored energy is the internal energy given by this equation. Right. Before we proceed further, I will try to go to the starting point. In that, whatever is important, if you feel everything, then you take the entire lot and we will be proceeding further. Okay. Yes. You may count on everything that is there shown in this screen. Thereafter, within a matter of 4 minutes or so, which will be time good enough for you to note down everything. Thereafter, I'll push up the screen, so there in the second explanation, whatever is there, you can also copy it down. Please copy down these details which is there in the next screen. தானே போடுறது See the next screen now. Side up. மேலே போ மேலே மேலே இன்னும் மேலே சைடில் போ இப்போ சைடில் போ ரைட் இன்னும் வா ரைட் Okay. So thereafter, moving on to what is there next after all the explanation till now. See now. So we have seen the definition of thermodynamics. We have seen what is a system, the types of system. We also have seen as to what is surrounding, and then the energy associated with the different type of surroundings, and apart from that, examples given. So to further, there is another important term which I have made a mention of but not explained, and that is the term property. So now, well, directly if I happen to tell you as to what is property under thermodynamics, it might be difficult to follow. So let us take an example that is there in our day-to-day activities. I have already told you, equivalent to whatever we study in our subject, equivalent to that we are having even in our daily activities. So you yourself find out what is the equivalent of whatever is studied that is there in our life. Bring it back to the subject. See how easy it is to understand. Okay. So now, you are going to your friend's place. He is taking you to some area where cultivation is there. He is also telling that in this area only we grow rice, little amount of wheat, and we have got a mango grove, and so on. So we get about 5,000 mangoes every year, lot of rice, lot of wheat, and whatever we want. Apart from that, all what excess is there, we sell it. From that, whatever money we get, using that money, we purchase other things, pay fees and so on, because of which we are managing to live. We live. Okay, then finally we will say, because of this property only, we are able to live. It is the biggest asset. This is our property. So from that, what can you understand? That property is your friend's own. Your friend is the owner for that property. So like that, whatever property is there for the gas will be the owner of the property. So like that, what are the quantities? Just check up. Let us take a chamber, and inside that chamber, it is filled with gas. Let us say that this gas will have some volume, and that volume is a 2 meter cube. Then, in this container, you remove 2/3 of the volume. So this is vacant, gap, vacuum. So remaining only will be gas. So first question is that in the vessel, how much gas is there? 2 meter cube. Okay. So volume is there for the gas. Now lot of gas is removed. Some gas is still there. What is the volume? 0.5 meter cube. Then now what you will do is that remove all the gas. So when you remove all the gas, then no gas. So here volume of the gas is 0. So when the gas is not there, volume of the gas is 0. So volume is not there. If the volume is not there, gas is also not there. Therefore, gas cannot live without the volume. Gas cannot exist without the volume. Like how your friend's land, without that land he cannot live. Because of that, it is your friend's property. Like that, without the volume, gas cannot live, gas cannot exist. So volume is a property of the gas. So volume is one property. Then, next, when gas is there, it will apply pressure in all directions. This is what is Pascal's law. If gas is not there, so no pressure acting on the sides. So pressure will be 0. So no pressure, no gas. So without pressure also, gas cannot exist. Gas is there, volume is there. Volume is not there, gas is not there, and gas is having volume means volume belongs to the gas. So like that, pressure belongs to the gas. And in the same manner, no temperature inside. When the temperature is 0, naturally there is no gas. This temperature will have a different unit. We are going to study about it later on, which is known as the absolute temperature or the Kelvin's temperature. If that is 0, it means there is no gas. Before that itself, everything is converted into liquid or a solid. So pressure, volume, temperature, everything is belonging to the gas. The gas is the owner for this. Without that, gas cannot exist. And what your friend told, that this land is his property, or it is the property of my father. So property is something which belongs to the system, without which the system cannot exist. No volume, no system. And volume is part of the gas. So volume belongs to the gas, without volume, gas cannot exist. So 2 points belongs to the gas. Without that, gas cannot exist. So 2 points satisfied. So the word property, the definition becomes complete. So my property means, what is the meaning of it? You cannot live without that. That is the main thing. For example, there is a very nice, very good table and a chair you have got in your house, costing about 7,500 rupees. Okay, really very costly. So it should be a good table and a chair. On the table you keep your notebook and you are writing the notes with your pen. So, table, notebook, pen, among these three, which is your property? Let us see that. It is belonging to you. Costly table, costly chair. It is yours, I agree. But it is not your property, even though it's very costly. Why? Because if there is no table or chair, you can still sit down, open the book and read and write. So table, chair, very costly, but still it is not your property. What about the pen? If your pen is not there, you cannot write anything in the notebook. So, if nothing is there, you cannot study the notes and you cannot write the exam. If you don't write the exam, no result. If the result is good, you will get a job. But no result means what? You will not get any job. If you don't get any job, no money. No money means you cannot eat anything. You cannot live. Pen 5 rupees or 10 rupees or whatever it is. Still, it is one of the important, property of your life for you. Pen belongs to you. Without that, you cannot survive. Therefore, according to the definition, pen is your property. But the table and the chair, no. So like that, even for a gas. Without pressure, no gas. Without volume, no gas. Without temperature, no gas again. So that is why pressure, volume and temperature belong to the gas. Without that, gas cannot exist. Both points satisfied. Therefore, pressure, volume and temperature are the fundamental properties of the gas. They are the properties. So, property is something which belongs to the gas and without which gas cannot exist. So that is the definition. Okay. And why they are called fundamental properties? Because from these properties only we are able to get other properties. We have got the stored energy, internal energy was one example. Then we have got relationship between pressure and volume. Because pressure is there, volume is there, relationship is also there. So other properties are derived from this. But for this, we don't have any other simplification. Without any simplification, we are having this. So this is the base. This is the fundamental. That is why pressure, volume and temperature are called the fundamental properties of the gas. Like that, there are totally 7 fundamental properties. One fundamental property is the Kelvin. Another fundamental property is the ampere, which is one current, and so on. All these 7 fundamental properties we are also going to study later on. So you have now got a clear idea about the word property. Okay. There are some more definitions which if explained and also used, then only you will be able to understand everything about thermodynamics. So now, those definition is what we have to see. We will see that now. Well, the first information is the pressure volume diagram. So, the pressure volume diagram. Right. As the name tells us, in this system, you can see only the pressure and the volume, nothing else. It is same like the 2 axes that we are having in coordinate geometry. One is the height called the y-axis, and another is the length, x-axis. So here, the y-axis that we have for thermodynamics is taken to be the pressure, and the length that we have is taken to be the volume. It is that just like that we have taken pressure as the height and volume as the length. There is a reason for it. We will study all that also. These reasons we will see it later on. And any one point you take here, let us say it is the first point, so point 1. That point is called state point of the gas. You know why it is called the state point? Because a single point in this diagram will tell us what is the state of the gas. If you see what is the height at point 1, it will be equal to the pressure. Height is equal to, you can see here, pressure is given by the height. Height is equal to pressure. And if you take the length at this point, length is equal to volume. So for this point, it will tell us how much volume is there. So the length for any point will be equal to the volume at that point. Height for that point will be equal to the pressure at that point. Pressure, volume, if you know pressure and volume, using that you can also find what is the temperature. Pressure, volume and temperature are the fundamental properties of the gas. So, pressure volume diagram is also called indicator diagram for two reasons. One reason is that this diagram indicates all the fundamental properties. Indicating all the fundamental properties, so the diagram is called indicator diagram. Indicator or indicator, all okay, diagram. Because it indicates all the fundamental properties of the gas. Every point in this diagram, different points, will all tell us the different state of the gas. Pressure, volume, temperature, how much. So the state is known. That is why the point is called the state point of the gas. It is called the state point. State point. There are so many other state points also will be there, but it will be having different name. State point 2, this one. State point 2. Okay. Then we have got the next definition, process. When some change is there, it is called a process, man. That's all. Not only with reference to a gas, anything, even in our life, some changes were there. You are going to the market. In your house, no vegetable, nothing. After buying something, when you come back, in your house, no vegetables are there. So some change is there. So when you are going to the market, after some change is there, so going to the market is one process. That's all. And for a gas also, you can see at point 1, the height. Pressure is equal to height, so at point 1, some pressure is there. And point 1, some volume is also there. So here, length is equal to volume. Equal to volume V1. At point 1, volume is V1. We have got another point, 2. Here, pressure is equal to height, so see what is the height here. That is called the pressure P2. Up to this point, whatever length is there, at point 2, it is volume V2 is equal to volume V2. So, one, pressure is different, volume is different. At point 2 again, pressure is some other value, volume is also some other value. So, pressure and volume, they have changed, means some change is there really for the gas. So, when a gas has undergone a change from point 1 to point 2, any change is called a process. So, when a gas has undergone a change from one point to another point, here also we say the gas has completed one process. So, if we join point 1 to point 2, then that change is called a process. So, remember, any change is called a process. I will make it even more thick, doubly thick. So, it is called a process. So, if anybody is asking you as to what is a process, then the answer is that when a system undergoes change from one condition to another condition, that is from one state point to another state point, it is then said to have completed a process. Then the next definition that we have, let us see that next definition is called a cycle. So let us see. Well, just now we have seen that process means some change. And that process in the PV diagram, we have shown it by the line 1, 2. It can be a straight line, it can be a curved line, it can be also curved upwards, depending upon how the pressure and depending upon the relationship between pressure and volume. Accordingly, you will get the curve for that process. So now I will show a smaller one here. Yes. Okay. So I will show a smaller one. Then this is the PV diagram. After that, let us have process. See, when the piston moves from top to bottom or one side to another side, then in the middle, one type of operation is over. Another operation is there for the second part. Means another process. Like that, one after another, so many changes are there for a gas. So another change means one more time pressure will change, volume will change. So 1 to 2 is one process, 2 to 3 is another process. So like that, when the piston is moving up, then for the first part of the motion, one type of process, then something else happens. First heat is supplied, now heat is coming out. So like that, different types of operations are possible. After all these operations, what happens is that it is a must that after some time, the system should come. So number of processes are there, then it will come back to its original conditions. So after number of processes, when the system, after undergoing a number of processes, is able to reach its original condition, it is then said to have completed a cycle. When a system undergoing a number of processes is able to attain its original conditions, it is then said to have completed a cycle. I have already told you, man, that whatever you study in your subject, that is what is going on in our real life also. For example, you see here that let us say that you are getting up from the bed at 6 o'clock in the morning. I am talking of a good student, ideal student. So getting up at 6 o'clock. Then what you will do? You will yawn like this. Because of that, what happens is that the laziness in our body will go out. So some change is there. So this one also is a process, man. Some change, any change, how it is, we don't know. We are not bothered. But difference is there. So that is also a process. Then you will brush your teeth. Brushing also is a process because now your teeth is fresh. The fluoride in the paste will remove the bacteria in your mouth. So your mouth is now fresh. So some change is there. And like that, after a number of changes, then what will happen? You will take bath and you will wear a good decent dress for going to the college. Then in the college you will attend the class. Attending class is also a process. Because before that your knowledge is less. After attending the classes, your knowledge is more. So attending class is also a process. Then you will come back to your house late in the afternoon or maybe early in the evening. Then you will play some game for relaxation. And after that, you come back to your house. I am talking of an ideal student. You will come back to your house at 5:30 or 6 o'clock. Wash your hands and legs. You study whatever has been taught in your class. Studying is also a process because after studying you become more intelligent. Before you did not know how to solve a problem on thermodynamics. After studying you are now able to solve. So you become more intelligent. Then like that, when it is evening time, say not evening time, night time, 9, 9:30 or 10 o'clock. Till such time you are studying, then you will go for food, dinner. After you go for food, so when it is 10 or 10:30, you then go to sleep. Every activity that I have told you just now are all process. At 10 o'clock you are going to sleep, then tomorrow at 6 o'clock you are again getting up from the bed. Note that point. Today at 6 o'clock you got up. Tomorrow at 6 o'clock you are again getting up from the bed. So, today morning and tomorrow morning you are having the same condition, getting up. So after a number of process you have completed, you have come back to the original condition. At that time you have completed one cycle. Yes man, yes, this is a cycle. So whatever you study here, that holds good even in our real life. After a number of changes, a cycle is a completed. Now, one student asked me, sir, what will happen if cycle is not completed? There is no output at all if the cycle is not completed. There is a proof for it, but that proof is very lengthy and it is beyond our scope. Well, you just see the timings for IC engine which I am going to teach. In that IC engine I am going to explain. If cycle is not completed, why you will not get continuous work. If it is an engine will stop. Why? All that I am going to explain there. So till such time, if a cycle is not completed, then we will not get continuous work. So that student asked me, sir, why? So for that, the answer is, yes, the answer is that, take yourself straight away for example. If at 6 o'clock in the morning you are not getting up from the bed, means yesterday night 10 o'clock you will not go to sleep. Without sleeping like that, how much can you manage? How many days can you manage? 2 days, 3 days? After that, in the class also you will automatically start sleeping. You don't want to sleep, but automatically your eyes will get closed. In the classroom, this is what will happen. So without going to sleep, you cannot complete a cycle. If you don't complete a cycle, cannot live. Take another example, taking food. So you have decided that in the afternoon I will not take any food. Like that, how many times you can manage without taking food? Today afternoon, then today night, then tomorrow morning. So you are going empty stomach. So after 2 days or even lesser than that, you will feel so hungry that anything you will try to grab from somebody and eat. So you will start eating. Your body will force you to take some. Because without eating, how many days you can manage? 7 days, 8 days, 10 days? Not more than that. If you don't eat, that's all man, gone. You cannot live. So eating is a must. If you again eat, means you are again coming back to the starting condition. So now you have completed a cycle. So what does that mean? It's very clear that if cycle is not completed, you cannot live. Like that even for a gas. Proof is there which if you want you can see it when I am teaching IC engines. So, so if a cycle is not completed, then you will not get continuous work. The piston will stop, no motion, no work output. So that is all, no use of having the engine. The gas itself will not be there. So if a cycle is not completed, continuous work then is not available. So that is the reason why we want complete cycle again and again and again. So when a cycle is not completed, is not completed. continuous work will not be obtained. Will not be obtained. So cycle, then the definition for a cycle. Both I have taught you before that a process and then details about a process. Also I okay. For a process it is here. So this is the process. Alright. There are more details that we have. So before looking into all the details, so please copy starting from the previous diagram. So here the cycle starts. Before that, copy down everything. Process, copy down everything. Should not take more than 4 minutes. Afterwards, we will proceed further. Okay, dear students, I know that there are very less students today because nobody knows that I am going to teach thermodynamics. So more and more days to come, we will be having more and more students also. And the request is that who are all your classmates? Please inform them. If you like my teaching, then please inform them. I want to first cover all the theory, then related to that theory, I want to go for the different equations and step by step. Then we will find out what is the work done, calculations. After the work done, we are going to take up the first and second law of thermodynamics. Thereafter, in that 8 to 9 equations will be available only from the laws of thermodynamics. Thereafter, you see, there are some people who say that there are third law. That's all humbug. Nothing is there. For that also, I will give you the proof. After the laws, there are a lot of problems that we will be working on from this chapter. That is properties of gases. Once that is over, based on your syllabus, we will be taking up next the second chapter. We have got the Carnot's ideal cycles and the entropy of gases. Entropy of gases also, I'll make it as interesting as possible. Quite an interesting chapter. But the thing is that at school levels or college levels, that knowledge is not there. To solve any problem on entropy, by understanding the problem, you have to understand the concept. And for that only I will do the teaching. I have given you some details about me. So you can remain rest assured, you can be confident that whatever I am telling you is definitely correct. While solving the problem, when you get the matching answer, that itself is an indication that whatever you have learned should be right. No, will be correct. Okay. So, copy down this diagram, then we will go to the diagram that is there for the cycle. Okay, now let us look into the other screen wherein we have got the details for a cycle. Right, so this is for a cycle shown here. Copy down fast. Okay. So I'll write down the definition of a cycle over here. You may please copy it down. When a system after undergoing a number of processes is able to attain Shankar on the screen page. இதுல கூட போடுறது அப்படியே. Is able to attain its original conditions it is then said to have completed a cycle. Yes. So that was the definition for a cycle, of course. Yes. So in continuation with the definition, what we have next is thermal equilibrium. And please note, I have already told you, I am saying it again. Here in this YouTube streaming class, which is for free, I will be covering the entire syllabus. The only thing is that due to restriction of time, instead of working 100 questions, I am working only 20 questions. So that is the only drawback. And if you still want to have a complete detail, like recording the details, and then more number of questions, and apart from the doubt clarification and test conducted with the marks and etc. Please join us as a regular student. That also will be online, but with complete details. Otherwise, for this YouTube streaming, we will have one class per week, 2 hours or 3 hours, depending upon how much more is to be covered and how much is possible during the course of it. Well, some explanations are not easy, quite tough. So then I will be restricting the time. Instead of 3, it will be just 1.5 hours or so. Otherwise, we will go even up to 2.5 hours or more at least, or 12. Okay. So then, we have next to say as to what is thermal equilibrium. Don't take it down now. See here. Let us take one body. Let us take another body. And this body is having a higher temperature. For example, say it is at 60 degrees. And that another body is, say, at 35 degrees in centigrade. Anything will flow, we know, from a higher level to a lower level. Take our own life, for example. Water is filled in a tank. It is then by a pipe connected to a tap. Open the tap, water will flow. But if you keep the top tap above the tank, no water will come. So flow from higher level to lower level. Current will flow from higher voltage to lower voltage. And heat itself you take will be flowing from a higher temperature to a lower temperature. So like that, for that matter, what you can see is that anything will flow from a higher pressure to a lower pressure. If you apply pressure to the gas, it will flow to another lower pressure. So a gas will flow from higher pressure to a lower pressure, and so on it goes, higher to lower. Money will flow from a rich man to a poor man. This is our life. Don't say, no sir, it is not like that. I am telling you by natural means, automatically. How did the rich man get the money? To the poor man. He will work on a machine, then sort of everything, then he will go to it. So, for money to flow from lower level to higher level, not only money, any energy. For that, the engineering is there in between. This is also first level. You see all the creator. Naturally, when you leave everything freely, then the flow will be from a higher level to a lower level. So when heat flows, it will flow from a higher temperature to a lower temperature. And after some time, this temperature will become 40. And the first body temperature will become 55. Then again, further, more and more heat coming out. This will become 50 and this will become 45. Then this will become 47.5. At that point of time, this will also be 47.5. Now there is same temperature for both bodies. Heat will flow from higher temperature to lower temperature. At this stage, there is no higher temperature, there is no lower temperature. So heat flow will flow. So now remember that when there is no heat flow, then the bodies will have same temperature. It's a very important information, even for studying thermodynamics on the highest level. That when there is no heat flow, then the temperature of the two bodies will be the same. And the thing is, if there is a low temperature, then definitely heat will flow higher to lower. Then, what is the definition? Thermal equilibrium. No heat flow. Heat means thermodynamics. Heat is at rest. So, thermal is at rest. That is why this combination is called a thermal equilibrium. So, what is the definition you should say when we are putting forth as to what is thermal equilibrium? When two bodies have no heat flow between them, they are then said to be in thermal equilibrium with one another. See the word between them. Between these two, no heat flow. Doesn't matter, doesn't mean that heat flow is not there at all. This can give heat to some other body. Like that also can give heat to some other body. Giving heat in such manner that all the two bodies will have the same temperature. Then there will be heat. The two bodies are said to be in thermal equilibrium when there is no heat transfer taking place between the two bodies. No heat transfer between the two bodies. Then they are said to be in thermal equilibrium with one another. So only between these two. It can give heat to some other body, but maintain the temperatures. Then there is thermal equilibrium. Right. So these are all the informations about thermal equilibrium, but note this point, that when there is thermal equilibrium, when there is thermal equilibrium. This is very important. Of course, one more thing, under ideal conditions, that's also important. Supposing actual condition, one body temperature is 60 degrees, another body temperature is 58, then according to definition, higher temperature to lower temperature heat will flow, but here no heat will flow. The reason is that from 60 degree when heat is coming out, it will have some particles that will object. So some heat will go to the particle. So it will become 50.9. Further, there are some more obstructions. Some particle, the heat will grow. Heat will flow. Like that, more and more heat transfers to the particle in between. So at one point of time, when that heat reaches the second body, the temperature becomes 58. So no heat flow. You have got a higher temperature. This is actual. For ideal condition, this only is correct. When there is thermal equilibrium, then the temperature of the two bodies will be same. Right. Thermal equilibrium, then the temperature of the two bodies will be same. Okay. Okay. Thermal equilibrium. And then based on this, we have got one statement which is known as the zeroth law of thermodynamics. So this zeroth law only, many people think that it is one of the law of thermodynamics. First law, second law, zeroth law. No, all that is not correct. If you will browse the net, then you will find what is zeroth law. Or just put is zeroth law one of the laws of thermodynamics. You will find that many of the statements you will find is that it is only an unofficial law. You see, for every information, it is being registered by an organization known as, what is it, American State or American Study of Mechanical Engineering, ASME. So there everything is registered. So there, under laws of thermodynamics, if you put zeroth law, nothing will come out. Or in some other statement, it is given as an unofficial law. Actually, how it all happened was that first law came first. Second law came there afterwards. Even after that, we were having zeroth law. This was a third law. But this third law, information was such that it should come even before first law. But before first, there was no number. So that is why before first, 0 is there. So they have kept this statement as zeroth law. So all the numbers have already come out. Whatever came lately, but it should be before the first law. Before first law, there is no number, so it was known as zeroth law. So that is why it is only an official law of thermodynamics. It is not real. It is not registered for in American Standard of Mechanical Engineering, ASME. Okay. So that is why I say it, please remember, I say it again, zeroth law is a law at zeroth level, zero heat transfer, therefore it is known as such. It is not a law of thermodynamics, remember. Okay. So we will proceed further now. Zeroth law. Let us take three bodies into account. This is one body. This is the second body. This is the third body. First body and the second body there is no heat transfer. First body and third body also, there is no heat transfer. Heat. Then, between the second and the third body also, now we are not checking this, but automatically it will be having no heat transfer. When two bodies are separately in thermal equilibrium with the third body, then the first two bodies will also be in thermal equilibrium with one another. So, first body, the second body, then third body, first and the second, no heat transfer. Second and the third, no heat transfer. Then the first two bodies also will be in thermal equilibrium with one another. That word one another is important. I have already made a mention of it. So this is thermal equilibrium. Therefore, if you want to make a note of it, it should be like this. That when TWO, two bodies, are in thermal equilibrium with one another, then the first two bodies will also be in equilibrium with one another. First two bodies. Also be in thermal equilibrium with one another. Yes. This is all the about zeroth law. So this is zeroth law. I have already given the heading beforehand. Right, okay. So, in continuation the definition, we have got more. And the other one is the all important one. For the entire thermal engineering, thermodynamics and whatnot, whatever be the subject in connection with thermodynamics, refrigeration, air conditioning. Then we have got some more IC engines. Then we have got what is automobile engineering and so on. Everywhere, what the definition that I am going to tell you now is of utmost importance. So then, let us look into that. And that is what is, you might have heard about it, but only 1 out of 100 knows the real meaning of it. The rest, they only, okay, I will remember. And then whatever result is there coming from there, they use that result, try to solve the problem. Sometimes you are right, sometimes you are wrong. So 50% chance are there to answer correct. But always to ask what is this quasi-static process, to see what I tell you and also note what I am putting on the board. So the next is quasi-static process. Okay. Now, quasi means partly, not fully. Static means all of rest. So, quasi-static gas partly at rest. Let us see a process. This is 1 and this is 2. So take some point in between. I will call it as a point A. Another point, I will call it as point B. Now, at point, what is the pressure at point A? 1.5 bar. What is the pressure at point B? Sir, 1.9 bar. No, it is too much of difference. Reduce. It reduces the pressure. Now you make the pressure 1.5 and here 1.7. No. That is also too much. Further reduce. So like that, as you keep on reducing, at one point what happens is that the final pressure is very, very close to the original pressure. No, further close it. Further make it close. No, sir, not possible. So like that, you have now come to one stage where the final condition is nearest to the original condition. Still closer, not possible. So this is nearest to the rest condition. So that is why we say that this process is partly at rest. That only is called a quasi-static process. Well, smallest thing, point 1, values A. Point 2, shortest distance. That gap is so less that you cannot measure this gap. You can only calculate. So, this is the difference where only calculation is possible. Difference only calculation means that only is called the differential calculus. So, a quasi-static process is the same as differential calculus. That is why change in volume for quasi-static process means we put dV, but then we put dW, and so on it goes. The heat transfer we put dQ, and so on. So wherever you get a dV, dQ, and so on, remember that this is a value for some quasi-static process in between. So now, a quasi-static process means, please remember that it is a differential. That change is that small is not possible, but only calculation is possible. Based on this only, you have got lot of questions coming in the examination. Let us take examination. You have got lot of questions coming. So that is why it's fairly important. But there are many people who don't know what is exactly the meaning of this. Well, I have seen even faculties, professors, they are teaching that when plenty of time is taken for one process, then it is called, that is one point, another point, the piston moves very slowly, next point, piston moves even more slowly. Like that, when full process is over, it is called a quasi-static process. Humbug, man. All that is nonsense. Right. I have written a book on this. So there, I have given a lot of details, and there has been full of appreciations even by professors of IIT. So it should be correct. Yes. Okay. So then, so remember, a quasi-static process is that process where the final condition is nearest to the original or the equilibrium conditions. Because this is under thermodynamics, you can say that the final condition is nearest to the thermal equilibrium conditions. This quasi-static process is also known as differential calculus, where the final condition from the starting point cannot be measured, but can only be calculated. Smallest difference, only calculation. That is why it is also known as differential calculus. The next thing that you have to understand is that why this quasi-static process? Why this differential calculus we have to use for making calculations that is there under thermodynamics. Let us see that. Well, the general equation, I will show the diagram. Of course, at present, we know only what is PV diagram, so that alone I will take. And we will show a process. You know what is a process? I have given a nice explanation for this. So this is a process. And pressure is given by the height, which we have taken it equal to P1, and at point 2 it is P2. Volume is given by the length, and that will be V1 here. At point 2 it is going to be V2. And here you can see that the pressure is changing. It's also changing. And the general formula for work done is, that also I explained today. W is equal to P into V, pressure into volume. But you know there is a condition here. It's a general equation, but that equation has also got a condition. And what is that condition? You see, that condition is that this pressure is a constant. That's the main condition. Here, you can see that every moment pressure is changing. Every time. The height is keeping on changing, man, here. At no time the pressure is constant. But your examiner is telling you, I don't know what you do. I want you to use only this for this and find out the work done. I want you to use this equation only for this process. Find the total work done. That is the question. So for that, what we have to do, there is no other alternative. There is no other alternative that you have to only take a quasi-static process. So when you take a quasi-static process means what? I have just now told you, don't have any doubts about it. If you give this information or whoever it is, they will simply laugh at you. But the question that I am going to work, give it to them. It is really wrong. If they say that this definition is wrong, they are also going to solve questions wrongly. So here, now I will use a quasi-static process to solve some problem which is given for the process 1 to 2. So for quasi-static process, I have to use that equation. The pressure is constant. Pressure is not constant here. Still you have to use that only. That is the condition they are giving in the question. So take a quasi-static process. What is the relationship between quasi-static and constant pressure? So for that, see here. At point A, see the height. Height is equal to the pressure. At point B, see the height. So what is the difference in the height? This is the difference. So this is the difference. So that will be PA minus P, PA minus P. Now if you this PA minus PB compared to the total pressure, this value is so less that if you put it in the equation or if you don't put, nothing will happen. You will still get the same answer. So that is why we say that difference in pressure between A and B is negligible. Difference is negligible means that is constant pressure. So for when pressure is keeping on, then change the difference in pressure for a quasi-static process is so less that we can neglect it. Let's take this volume P equal to dV and let this pressure be pressure P. So here we are making an assumption. The difference is so small that the change in pressure is negligible. So here pressure is constant. So quasi-static process and pressure constant matches. Because it is a very, very small change. So work done also will be very small. So that work done so small that it will be given in the differential form. That will be equal to P, change in volume is dV. So this is what is the work done for a, how to put it? And then what we will do is, quasi-static process means, as I have already told you, it is all you can see in the differential form. Then what I had already told you is, that if quasi-static process is almost like a constant pressure condition, then find the work done for all the quasi-static process from beginning to the end, for all the quasi-static process. Add up everything. So when you add up, you have to find for all the different work done for all quasi-static process from 1 to 2. When you add up here, of a different type. The summation is of a different type. That is why we are giving a different name to it. This summation, we are giving a different name to it, which is called integration. So integration means sum of. Sum of what? All these values. So sum of all these values is equal to integration from where? From point 1 of the process to point 2 of the process, and then it will be into PdV. So this is that all important equation which we use. Now integration means sum, maximum. This is minimum. So when maximum and minimum directly they come in contact with one another, then that gets neutralized. So what you will get is therefore the work done is equal to integral 1 to 2 of PdV. Very people only know these PdV. Very few people only write. Now everybody knows W is equal to integral 1 to 2 PdV. Why? Oh, from the quasi-static process. Why we take keep on asking questions to them. Why do we take quasi-static process? What is quasi-static process? They will give only the explanation very slowly. Then the total process becomes quasi-static. All rubbish, man. I have seen even PhDs giving that answer. It is not at all correct. With this, I give you the assurance. I promise that all questions you can solve it correctly. According to that other idea, you cannot solve all questions correctly. So remember, quasi-static process is the same as a differential small change. It is the same as differential calculus in mathematics. So no difference. Okay. That's why I have told you. Attending class is different, studying by yourself is different. So this is very important. Okay. So then, now, when pressure is not constant, then the value of this pressure will be different for different process. Different process means what? If we take a solid body, the motion, if we take a solid body into motion, then during its motion, velocity can be constant. Okay. So during its motion, velocity can be constant. So a body here moving from here, so moving from here to here, say point A to B. So at the beginning velocity is u, at the end velocity is v. It will cover some distance, and also some time will be taken for covering the distance. There are different manners it will cover the distance is. It is a constant velocity, it will reach the final point. So first condition is velocity is constant. Second condition, it is velocity increases more and more, but starting point, velocity is 0. Then, third point, acceleration itself is changing. Acceleration is not constant. Then fourth, in a general form, when acceleration is changing, in a general form, for the distance covered, the equation is ut plus half at square. Like how we are having different equation for the motion of a solid between same 2 points, like that. One end of the piston to the other end of the, one end of the cylinder to the other end of the cylinder. there can be different type of motion for the piston. So one is that for that flow, the pressure can be constant. Pressure can be constant. Second, volume can be constant. Third one, pressure is changing, volume is changing, but the temperature is constant. Fourth, no heat is supplied. Pressure changes, volume changes, temperature changes, but no heat is supplied. And the name of that process, this is all something which you have learned. But these basics that I am explaining you will be something that the hidden informations will come out here. Only for that the basics are important. And then the next one is pressure changes, volume changes, also changes, heat also supplied. How much? We don't know. See, when you are having a figure covered by 3 sides called a triangle, 4 sides, quadrilateral, 5 sides, pentagon, then hexagon, septagon, octagon, nonagon, like that it goes, decagon, dodecahedron, and so on it goes. So like that here, when we don't know how many sides are there, then to cover a figure, to cover some area, it is called a polygon. Like that here, when we don't know what type of here, it is known as a, like polygon, here it is a polytropic process. Tropic. So we are here after subject. These are the details that we are going to see. So for all these different type of process, when you take pressure, it will have different equations. Put that equation equal to pressure, simplify. You will get 5 different equations for work done for 5 different processes. That will be always remaining the same. It will never change. So that is what we have to see next. Right. So if I cover it up today, then for beginners it will be a little confusing. So that is why I would like to take it up. Next class. And next class, remember, there is YouTube streaming, same time, same day. I will continue from where I have left. Okay. So for those who are this down, then I will go to the previous page. So you may copy it down. So quasi-static process was the start. So perhaps this is the only page that we have. So make a note of it. After take it down, then shift sideways, so that you can also copy down this. Fast. Huh? Yes. So copy down the leftovers. And with this we end the class today. When you come for the next class, I will continue from where we have left exactly. So, till such time, good day, and let other days also be good. But please practice. All of which is not available in the books. And besides that, without this, the study will be incomplete. And after this, if you work out problem, it will be appearing to be so easy, all of you. Thank you very much.